Hi, good morning everybody. Welcome to this morning's webinar by Pilz Automation on access permission systems and functionally safe operating mode selection, which will be incorporating our pit reader and pit mode devices. My name is Jason Reed. I'm one of the account managers here at Pilz. You can type questions using the toolbar that you can see on the right hand side of your screen, and in the background are two of my colleagues, Alex Bryce and Jeremy Thomas, and they'll do their best to answer questions that you may have during the webinar. If they can't, we'll get back to you as soon as we can afterwards. I've had feedback, so you should all be able to hear me okay. You will automatically receive a link to a video of this webinar a few hours after it's finished. You won't automatically receive the slides. They are available, and if you'd like a copy of the slides, then please just make a note in the questions section, and we'll send them to you. So the agenda for today's webinar. There'll be a product overview. We'll run through the basics of access permissions. We'll look at the standards. We'll have a look at the basics of operating mode selection. We'll run through technical data and details. We'll look at the software that we use, and then we'll wrap up and just run through future webinars from Pilz. It's worth pointing out that, that during the presentation, you're going to see a number of boxes that will either be blue or orange, and that's going to indicate whether it's for access permission or whether it's for selecting the safe operating mode. So with safe operating mode, we normally have a performance level associated with that. For access permissions, we don't, but we'll run through that during the webinar. So what issues do we face in the work environment? So what daily challenges are there in the operation of machines? So unfortunately, colleagues can suffer serious injuries. Companies can be held responsible. We can have machine downtime costs due to switching machines on or off when they shouldn't, or getting access to something when they shouldn't. We also have data loss and theft of know-how. So with devices that we run through today, we can look at employee protection, liability protection, productivity protection, and data protection. And when we talk about safety of machinery, we are protecting people from the machine, so your employees, visitors, etc. And that can be from protection against moving parts, but we also need to protect the machine from people. And by that we mean that we want to prevent unauthorized access to the machine, somebody getting access to the HMI or programs that aren't authorized, etc. So which access must be protected on machines? So we need to look at process access. So this is who has the ability to gain access to HMIs, your controllers, PLCs, etc. Safe process access. So this is safe operating mode selection. So how can we change the machine from one mode to another in a safe manner? We have physical entry, which would be via doors and flaps. And then we have remote cyber access. So again, to HMIs, PLCs, but remotely via cyber attacks. So how can we benefit directly from security? So with permissions, only trained, competent, and authorized users have access. So therefore, productivity increases due to the clear responsibilities that they have. Effective know-how protection, and clear user levels, especially on complex machines. So, as mentioned with the HMIs, not anybody can just go up to a HMI screen and gain access to it. We also have the availability, so prevention of system failures and downtime which gives you cost savings due to fewer downtimes and fewer repairs and maintenance tasks. So, if it was a trap key system, for instance, or just any downtime on a machine, not anybody can just stop the machine. Only trained, authorised, and competent personnel can actually stop the machine when it's required. And then transparency. So performed operations can be clearly assigned to a user. So individualization means higher levels of identification of users. Passwords are not secure. We'll run through that later on. Not personalized, and they're commonly known. And the ability to provide evidence in the case of a failure or an accident. So this chart here, really, if we look at the technology across the top, this is given the different technology that's out there, from keys, passwords to body scans, for instance. And then on the left-hand side, we have different criteria such as safety, reliability, misuse, administration effort, etc. And if we look at keys, mechanical keys, these generally offer none or very low levels of safety. The reason being is that keys, are typically left in panels. They can be handed out to colleagues that then share the keys. Maybe an engineer, due to time pressure, has gone onto a machine to look at a breakdown, has used their key to change the mode of the machine or to put it into a bypass state. Then they've been called to another operation and they've left the key there. They may have told their colleague, hand me the key back when it's finished, etc. They are reliable, but again, there's administration effort because you need to log who's got what. Passwords, again, generally offer none or very low levels of safety. The reason being, again, is that passwords are easily shared. It may be that you write them down on a post-it note, they're on the panel, and so before you know it, it becomes common knowledge as to what that password is. Also, if employees were to leave, if you were an OEM and within your software you have a password that only your technical guys use, if they were to leave, if they went to a competitor, or if they were to set up on their own business, they could keep that password with them. So still in the future they could gain access to that part of the program. So you'd need to be able to protect that, and you can do that with RFID and stroke near field communication, which is what we'll be looking at today. So RFID is contactless communication via electromagnetic waves for identification of people and goods. And we use our system with near field communication. And what that means is similar to your phone, but where you can just swipe that over a reader or have it in the vicinity of a reader, with the actual key that we use, that actually has to physically fit within the key reader itself. Otherwise, the RFID data won't be transferred over. You then have got other technologies such as fingerprint, iris scanning, facial recognition, etc. All offer completely and very high levels of safety. But generally, the total cost of ownership and the administration effort is generally high to administer those. And though the majority of us are happy to have our fingerprints and face recognition on our phones, on our own technology, I think when it comes to sharing it with our employers or other organisations, then it becomes a bit more difficult. So RFID and near field communication kind of strikes a happy medium. So a product overview from Pilz. On the left-hand side, we have our Pit Mode Classic, which was the first unit that we launched into the market, and that offers both access permissions and functionally safe operating mode selections. It's compact. It's a all-in-one integrated solution. So the reader, the keypad for selection, and the safe evaluation device is all in the one unit. We then have our Pit Mode Fusion, which is a modular unit, again for access permissions and functionally safe operating modes. This can be used with either a Pilz or a third-party functional safe controller, and it's made up of a membrane keypad to select the modes and the pit reader and then we have a safe evaluation unit to determine the mode that's been selected via the key, and then outputting that to the fail-safe controller. Our PIP mode flex and PIP mode flex visu systems, the difference with those is that there's no safe evaluation unit. The safe evaluation is done within the program software within the Pilz functional safe controllers. Still require either a membrane keypad that can be the Pilz unit, or it could be used via third-party push buttons. But in the case of the Flex Visu, it's done via touchscreen HMI system. And then finally, we have standalone units, which is our PIP reader device, and that's purely for access permissions. And that can be used for security access authorization for HMIs, and for process and door guard locking or access, and connection is via the PLC and HMI systems. So a bit more detail on the PIP reader. The electronic access permission system using the latest RFID technology. It's a compact device for controlling all access permission tasks. It's suitable for use in rugged industrial environments, and it's easy to retrofit due to the standard diameter of 22.5 millimeters, and its very low modular depth of just 45 millimeters. And the back part is probably the size of half a pack of cards. The user authentication is done via the transponder key with RFID technology. All functions are programmed via an integrated web server, and the communication is via Ethernet for security, and serially with the safe evaluation unit. And it's a 24-volt standard output if the transponder key that's being used is valid. And we have front protection of IP65/67, and we can also use it, as you can see here, in our PIP gate box, and we use that our PIP gate box reader, and that can be used with our modular safety gate system. So I'll skip this page, but if you have a copy of the handout, of the presentation, then you can have this for future use, really. But it's giving you the two standard base units that you can use for the PIP reader, the adapter itself, and then the keys, both transponder keys and generic transponder keys, which we'll run through in a bit more detail later on. So controlling access permissions with the PIP reader, what this allows, and the various areas of use, is it allows you HMI visualization, so personalized user identification, so it's a password replacement, so you no longer need a password for your HMI. You can control, edit, read permissions, you can display pages, and the user has the option of switching languages, for instance. You can get it for access to controller and PLCs. With that, you could use it to activate functions, toggle different variants, use it to set recipes, for instance. And we've also launched a USB reader as well. It can be used to activate that. Again, for security. And then we have the door access permissions. So the access permission management for industrial doors and gate systems. So any authorized person have access. The benefit there really is, with conventional systems where you may have a key that resides with the door itself, like a trap key system, is you may have many keys on site for all of your doors. With this system, you'd only have a key per operator that is trained, authorized, and competent to use the system. And their key really can then be used to go round to any part of the access permission, PIP gate readers in this case, to be able to gain permission to gain access to open the door. And if they have got permission, then they can use their key. If they haven't, then it would block them. But the benefit of that, again, being that if a key was lost or misplaced, With a conventional mechanical system, you'd have to reorder the duplicate key. If that original key that was lost was then found, you've effectively got two keys of the same code on site, which would mean that you could override the system. With ours, if a key was lost, you could block it. And then finally, we have safe operating mode, and that's access permission management for functionally safe operating mode selection. So again, only authorized qualified personnel can safely switch operating modes of the machine. So I'll just do a video now. So this video here, you can see we have our pick gate reader. We have our S-lock and door handle. Machine's running. The interlock is lock closed. You can't open the door. You can see that the LED light on the pit reader is blue to indicate that it's on. I've inserted a key, but this key is not valid. So you can see that it's gone red, and it won't allow me to open the door. The door is still locked closed. So I come along with my key. If I've got the correct permissions, you can see the light comes on. We've programmed it so I have to remove my key, which would then allow the lock to be, the solenoid to be energized and the door to be opened. If I left my key in there, the door would remain locked closed. If somebody comes along and closes the door behind me when I've entered with that key, they can't lock it. So I have to come out, I have to close the door, put my key back in. That would then allow me to energize the lock, locking the door closed and restarting the machine. We also have in this instance, if somebody was locked in, then you can use the emergency release to open the door and come out. It's worth pointing out, if there was more than one operator that was gaining access to the machine in this case, then we do and will have the functionality of being able to log multiple keys within the area. So once one person has gone in and registered their key, second, third, fourth, fifth, sixth, etc. person can put in their keys and register that they're within the area as well. Only when all 6 or 7 have come out and logged their keys to say that they're out could you then restart the machine. So the operating principle, the transponder keys contain various data. So this could be device group permissions, and we'll run through that, and information, which could be a unique security ID required for permission management. And the pit reader can read and write the contents of the transponder. And the contents of the transponder can be read and interpreted by the pit reader, including the control of the LED ring, or it can be forwarded directly one-to-one by the pit reader without evaluating the data or controlling the LED ring. And as we saw in the previous video, the color and the flash modes of the multicolored LED can be controlled and overwritten via the Modbus TCP connection. And the colors that we have available are blue, red, green, and yellow. We typically use blue to show that the pit reader is active. We have green for if it's a valid key. We have red if it's invalid. But I've not used yellow yet, so if somebody has an idea for that, we can use that one. So what are the kind of functions that we can use for safety and industrial security? So just to confirm, really, we have operator A and B. We've got machine A. Operator A can gain access to the machine. Operator B can't. They don't have the permissions. They're not trained. We can have group-based management rights, and so the person on the left, they've got access to both groups of machines, whereas the person on the right, they've only got access to the machine on the right. We can have time limitations, and so this means that if you have systems in place, procedures where you have to have an operator trained every 12, 18, 24 months on a machine, then you can set those times limitations up on the key itself. And so if the operator hasn't been retrained, then the key would just not work until they'd had the training and you'd revalidated the key. You could also do it for contractors or any visitors that are on site. You could issue them with a temporary key with different group and permissions. And again, that could be time stamped for the length of time and duration that they're expected to be on site. User-defined permissions. So again, person A, in this case, can change the language to German. Person B can change it to Italian, but that could be that you could change ingredients, recipes, for instance, programs on a machine. You have a block list. So if you were to lose a key, that key was to be found. You can block that key. So if you've issued a replacement, you can block the key that's been lost, so it can't be used. But also you've got traceability of whose key it is. You can have conversations with regards to how they should manage the key, etc. But you've got traceability of that. And you've got the logging of actions, so you can see what key is being used, where and when. And also, and then finally, you've got the safe operating mode selection, where we can change the machine safely, in this case, from automatic mode to service mode. And this gives us all authorization and traceability of safety and security on the machine. So comparisons of the basic functions, if we look at the transponder data, the key, and the HMI PLC, so external user management, so via external evaluation of the security ID is for both. Access, so the access to buffer is via Ethernet, so access to all data from the PIC reader and key group permissions is applicable to both. The LED control is done via the key, so the control of active, but it isn't with the external, with the HMI. Evaluation of the transponder data, so all transponder key data is evaluated in the reader, but the transponder key data is only forwarded one-to-one by the reader for external evaluation. And permissions of operating mode selection, so only permissions in the assigned transponder key group within the key, and there's none within the external, within the HMI PLC. So just another video. So in this case, we're looking at access authorization via the PIC reader and evaluation on a HMI system. So our operator will come along with his key, place that into the reader. You see it's gone green. Their ID is number 41, and they can only read. All they can do is read what's on the HMI. However, their colleague can come along, he puts in his key, his ID is number 56 in this case, and he's got the ability to edit, again, because of his training, competency, and authorization. So if we take a look at the standards, applications of PIC mode fusion in accordance with the standard EN ISO 16090 Part 1, which is a machine tool standard, is for safe selection of the mode of safe operation. An operating mode selection can generally be divided into three areas. We have access, selection, and activation. So access is what we class as security, and that's via electronic key or a comparable solution. We have then the safety, which is selection, which is a device for selecting the operating mode. So in this case, it's our keypad or third-party keypad and our safe evaluation unit. And then we have the activation, which is forwarded to a functionally safe controller, again, either Pilz or a third party. So no safety requirement for access systems. It ensures that only one operating mode at a time is selected and activated. And the selected operating mode must be clearly displayed. That's what it states within the standard. So within the standard, Table 3 has an overview of machine groups and the modes of safe operation. If we look at group 3 and 4, it's saying that if you have automatic or setting mode, they're mandatory. So at least two modes of safe operation are specified as mandatory for machining centres and special purpose machinery. MS01 being automatic, MS02 being setup, and then there's an MSO service mode. It also states that the performance level required is absolutely essential when more than 2 modes of safe operation are required. That should be a minimum of C. So the Pilz functionally safe operating mode selection functions offer the following performance and seal levels. For applications up to PLD Cat 3 in accordance with ISO 13849, and for applications up to SEAL 2 according to EN 62061, so that's performance level 2. Right, I've just been told that the sound might be dropping out, so I'm just closing what I may have in the background. Right, hopefully you can hear me okay still. So basics of functionally safe operating mode selection. So the operating mode selection and access permission system, PIP mode, are used on plant and machinery that require various access rights and functionally safe operating modes. Both functions require comprehensive manipulation-proof permission management. So the basic principles are: the permission is evaluated by inserting an RFID-based transponder key. The permissions on the key specifies which operating mode can be selected. The operating mode is selected via the corresponding LED button, and the final evaluation of the operating mode is made via a safe control system. And there are 5 selectable operating modes, and they're in a structured hierarchical order. So we have MSO1, which is automatic mode, 2, which is setting mode, 3, manual intervention under restricted operating conditions with enabling switch. We have 4, which is a special mode or process monitoring without an enabling switch, and we have service mode. And it's worth pointing out that if you press or you have the if you have the coding level 3, let's say on your key, because it is a hierarchy structure, it means that you have the ability to not only press 3, but you can do 2 and 1. So if you have all 5 options, then you can do 5, 4, 3, 2 and 1. If you're only given an option MSO2, then you can only do 2 and 1. So the RFID-based transponder key, the accessible operating modes are defined by the inserted RFID-based transponder keys. Each key can be individually coded, which effectively excludes manipulation. The functions of several mechanical keys can be combined within one transponder key, thereby reducing the administrative work. Because if you've got access to a group of machines or many groups of machines, the one key will work for all. You don't need one for each. Various types of transponder keys are available from ourselves, each with different hierarchical permissions. And so you can buy standard transponder keys from ourselves with the levels programmed, or you can buy generic transponder keys which you can program yourselves. But they're only for use with our PIP reader device, not the original PIP mode classic unit. So if we look at a standard machine, in this case we've got a pallet wrapper to 415 part 6. We've got a number of safeguards that are on that machine, e-stops, light curtains, interlocks on the guard. And normal operation would be that an unwrapped pallet would go along the in-feed conveyor, break the muting sensors, which would allow it to go through the light curtain. It would then be wrapped in the machine, and then it would go in the outfeed conveyor off to distribution. if for any reason the operator needs to come along and run the machine with a guard open, and therefore defeating, bypassing one of the safeguards, in this case an interlock, they can do that via in this case the pit mode unit, but only under certain conditions. So in this case, the operator is trained, competent, authorised to do so. They'd come along with their key, insert that into the pit mode unit, select the correct mode of operation via the keypad, and if their key has the correct permissions, etc. on it, then it would allow them to then open the door, use in this case, it may be a jog or an enabling switch to run the machine at a slower speed, but they can view it safely. When they've finished, they can take the key out, and that would automatically put all the safeguards back to their original state, or you can actually time how long the safe mode of operation is active for. So you may say, okay, this particular process will take a minute, and so therefore we'll allocate a time of a minute for mode 3, for instance. But yeah, if they were to rush off and take their key out, or somebody was to take the key out, it would automatically default back to its original state. We can also look at 14119 for interlocks, and so if we look at the chart for manipulation to defeat, and if it is possible to eliminate or minimise the motivation to defeat of an interlock, then we need to look at doing that by implementing design measures, and that's normally by implementing alternative modes. And so in this case, again, it may be that we use a pit gate with a pit reader. We insert that. That allows us to change the safe operating mode of the machine. And in this case, again, we use an enabling switch. We'll have an encoder to monitor the speed of the machine, etc. So again, another video. So this is a functionally safe operating mode up to PLD. Option 1 would be our reader with our evaluation unit and a third party or a Pilz fail-safe controller. Option 2 is the reader, but with one of our controllers with the software inbuilt. So in this case, the operators come along with their key. It's green, so that it's a valid key. It's communicating to the controller to say it's a valid key. They're going to then use the keypad to enter the safe mode of operation that they wish to achieve. That's going to the evaluation unit, and if it's agreed, they can have it. They've only had permissions 2, but their colleague comes along and they've actually got permission 5. And the key guy on you will probably think, well, there's only 4 push buttons on the membrane keypad. How are they achieving level 5? In this case, it's a long press on key number 1. We'll then put it into safe operating mode 5. So just to go into more detail with regards to groups and permissions on keys, there are 32 device groups available. So the pit readers are combined within a device group when a user wants to have the same permissions evaluation. And device groups can be used for a machine type. So it doesn't mean that you can only use it on 32 machines. It's 32 device groups. So if you've got 13 milli machines, 20 presses, you can group those into machine groups. Each user has exactly 1 permission per device group, and a permission can mean the enabling of operations, which the users are granted due to their level of training competency. And there are 65 of these, 0 being no permission up to 64. And only permissions 1 to 5 are accepted for use with the safe evaluation unit, as they're the operating mode selector switch. So that's where we have our performance level associated with it. All permissions from all groups can be read out at any time by the Ethernet interface, regardless of the mode. So device group example, for example, the group G3 is assigned to the pit reader. permission 2 in group 3 on the key is forwarded to the safe evaluation unit by the PIP reader. And permission 2 means that buttons can be used to switch operating modes 1 and 2, as previously mentioned. So transponder date mode for default group 1 permission evaluation. So this is how we're going to program, really. So you can see we've got a transponder key here. It's a generic key with 32 groups and their permissions. And you can see that this particular employee has group 0 with permission 3, group 8, permission 7, group 31 with permissions 4. So on the PC, we're looking at group 0. That will be fed via Ethernet to the PIP reader. The key is placed within the PIP reader, so that's reading whether or not group 0 is on the key itself. It is. So that will send via the serial port to the safe evaluation unit what the permissions are on the key. Then via the keypad, the operator would press the safe operating mode. Because they've got permission 3, they can do 3, 2, and 1. That will be outputted to the functional safe controller, which will then handle the safety side of the machine, but also via the Ethernet, it would also send the data and security to the PLC and HMI. So in this application here, we've got device group 1, a couple of machines, and we've got device group 2. So here is my key, and for device group 1, I'm fully trained, authorized and competent for all permissions and operating modes, so I can do all 5. But for group 2, I've only got permission 1, so I can't do any of this. Again, based on my training competency, etc. Web server encoding, so status information is displayed, IP address is set, you can have date time settings, operational functions are defined, communication settings by Modbus TCP, you have the transponder key is written with group permissions and coding, and coding is understood to be the process whereby transponder keys are taught in for a PIP reader, which must have a specific identifier. And this means that only taught-in company-specific transponder keys will work on company-specific PIP readers. So you can, like anything else, the more you put it in, the more you can get out of it. You can actually lock the keys down to company-specific PIP readers. And the way that we would do that, the way that we generate a company-specific PIP reader and transponder keys is we have our PC connected to the PIP reader via Ethernet. Password inputs plain text into the protected area of the web server. That's placed on the PIP reader. We save. When we save that, it creates an encrypted password in the PIP reader. The teach key creates a signature on the key for the encrypted password and the contents of the key. And the signal is located in an accessible area of the transponder key. And where transponder key is inserted, the signature is calculated in the PIP reader from the content of the key and the encrypted password of the PIP reader. The signature generated on the PIP reader is compared with the signature of the transponder key, and if the signatures are identical, then the key is valid, and you can see that the LED has gone green. The LED ring has gone green. If it isn't a valid key, so it's one that hasn't been taught in, and it's got another signature, you can see that it's invalid, and it will flash red. I've just been told that my voice may be going a bit robotic again, so if it is, I apologise. But hopefully it's coming back in now. So transponder key functions. On permission keys, so we have 2 types of keys at Pilz. Permission keys that already bring a fixed permission, and the group area is factory locked. So this area can't even be modified by Pilz. So you could buy permission keys from Pilz with group permissions already locked in. And on generic keys, both the group and the user area can be modified. The generic keys can also be locked as an option, so preventing any retrospective changes. In the user data area, additional only own parameters can be created in the transponder and filled with data. And these can be a username, a cost center, individual codes, email addresses, etc. The parameters defined by the PIP reader web server. The definition is stored in the PIP reader for evaluation of key content. The created parameters can be assigned to device groups. There are two types of parameters assigned to device groups: default assignment, and this means that a corresponding parameter is present in all device groups, such as a username. And then we have device group assignment. This means that the corresponding parameter is only valid for a certain device group. And this assignment overrides the default assignment. If we then look at our products in a bit more detail, if we look at the PIP mode fusion, access permission system is a PIP reader and the operating mode selection in a modular system for coupling to all functionally safe controllers. And it consists of the PIP reader and the safe evaluation unit. And the access permission control and 5-step safe operating mode selector switch. So that's the membrane keypad that could either be our unit or it could be third party. It fits into the machine design thanks to its modular structure, and it also enables the use of third-party buttons. The PIP reader, as mentioned earlier, is standard installation, slimline safe evaluation unit. Again, the IP protection we ran through and the performance levels up to PLD. So what does that look like? So here's a kind of an overview, really. So we have our PIP reader that is connected via Ethernet to HMI or process controller PLC. We then have our keypad or third-party keypad that is connected to the safe evaluation unit and then to a third-party or a Pilz fail-safe controller. When we insert our key into the reader, it will send out data via Ethernet to PLC. It will also send out serially to the safe evaluation unit. And as discussed earlier, if the operating mode that's selected by the keypad marries with what's on the key, then the safe evaluation unit will output that to the controller. So this is where it's, again, this is where it's orange and it's safe. This is where it's blue and it's security. We also then have our PIP mode, so the PIP mode fusion. These are the components that are used within that. Again, I'll leave that for you really for handouts and to look at in the future. We then have our PIP mode flex and flex visu. So again, it's an access permission system PIP reader and safe operating mode selection with Pilz functional safe controllers. So it has to be used with a Pilz controller. The modular system consists of PIP reader, safe controller from Pilz. So it could be a MB1 or PSS 4000, for instance, and the selection of the safe operating mode is done via push buttons for the PIP mode flex or via a touchscreen HMI for the flex visu. And you can actually control up to 8 safe operating modes with this function, not 5. How does this work? So again, blue for security, orange for safety. We insert our key into the reader. That will then transfer it to either the MB1 or the PSS 4000. You will select the safe mode of operation via the keypad for the flex or via the HMI touchscreen or the flex visu. That will then go to the controller. And if that marries up with the information that's on the key, it will then send an output to the machine to put it into the mode that's been selected. again, component parts, which I'll leave you to look at in your own leisure. We then have the compact, the original device, the Bitmode Classic. So this is really where it's combining all of the previous things that we've seen into one module. So it's your keypad, your reader, and your safe evaluation unit all into one small housing. And the connection again would either be outputted to a PLC or again via a Pilz or third-party functional safety controller. The components associated with that. This is general technical data of how a PIT reader would be connected, which I'll leave you to look at your leisure. The dimensions, so you can see the connection of the safe evaluation unit and the modes, power supply, power required, LED status lights. Dimensional drawings again for the keypad that we use. We also have launched a USB device. So it means that if you've got a USB on your machine, you can't just freely stick a USB stick into it, which could cause quite serious damage if there was a virus, etc. Or if somebody wanted to extract data from your machine, etc. So we can disable this. So only trained, authorized, and competent people can activate it. So you would insert your PIT reader, your key into the PIT reader. If you're trained, authorized, and competent, you would send out a 24-volt signal to the USB device, which is connected typically, or an example would be via USB-A lead. That would then allow you to activate and gain access. Again, I'll show you a video of that in operation. Here is the USB, here's our PIT reader, here's our membrane keypad, and there's our safe evaluation unit. You don't have to have it with the safe evaluation unit, you could just have the PIT reader and the USB. I've got it connected via my phone, so you can see that the ring is blue to indicate that it's active. There's power on it. I put my key into the reader. You can see that will go green to say that it's an active key. The LED lights come on the membrane keypad. In this case, I'm pressing mode number 4. When I press that, if mode number 4 is on that key, you can see that the USB goes green to indicate that it's active, and then you see that the phone came on as it's charged. If I take the key out, you'll see it will automatically switch back off and default. But as mentioned, you don't need the safe evaluation unit for this part. You can do it just with these two components. Again, a bit of a review of the software. So it's a desktop tool to manage users and their transponder keys. You can manage transponder keys and assign them to users. You have the management of all qualified users in the project database. Allocation, programming of permissions, can be individual or via predefined templates. Programming of transponder keys via a connected PIT reader. You can set PIT reader device groups, and you can manage block lists, etc. And transfer those block lists to PIT readers. So to kind of wrap up, what are the benefits of the operating mode selection and access permission systems? So they're functionally safe switching of the operating mode through self-monitoring, it's PLD. It's a control of access permissions. You've got high manipulation protection through company-specific coding. It's integrated web server for configuration of the PIT reader and transponder keys. You can read, write, and data storage on keys. The teaching of transponder keys on the PIT reader via coding. Locking of data areas on the keys. Pre-installed group permission rights management. You've got an integrated user management and you've got the multicolour LED ring for user information. So that about wraps up the webinar for today. I apologise if there's been any dropouts with the sound. We'll have to check our end what has caused that. All previous webinars can be viewed at our go-to webinar stage, which you have access to, and I suppose also if there's any topics that you'd like Pilz to cover in the future, then you know, by all means let us know in the comments field. So I hope you've enjoyed the webinar this morning. It's been informative, and that we've answered any questions that you may have. If we haven't, we'll come back to you in due course. And all that's left for me to say really is have a great weekend.